to just add to the force and motion notes we've already started. We've talked about potential energy, kinetic energy. We did the speed formula already, okay? And then we talked about the relationships between speed and kinetic energy, and then mass and kinetic energy, okay? We've already done that. So today, we're going to focus on those graphing relationships, which is going to help us understand who has a bigger impact, speed or mass, okay? So graphing relationships. Okay. During activity 5, you guys made graphs using data. Okay. Half of you made the speed versus kinetic energy graph, and half of you made the mass versus kinetic energy graph. So we're going to figure out, using those graphs, which one has a bigger impact. Okay. Let's start with mass versus kinetic energy. Okay. What kind of graph is mass versus kinetic energy? What kind of graph is that? Linear, right? It's linear. And how can I tell just by looking at the line that that is a linear graph? Because it is straight, right? It is a straight, nice and flat graph. So I can tell automatically just by looking at the line. I don't even need to look at the units, the scale. I can just look at the line, and I know that that's a linear graph. Okay? So mass versus kinetic energy has a linear graph. Sorry. Okay, and we can just draw a little quick picture to the side so you remember that a linear graph is a nice flat graph like that. Okay? So mathematically what that means is whatever I do with one variable, the same thing happens to the other variable. Right? So if this is mass and this is energy, whatever I do to mass, kinetic energy does it too. Mathematically. Okay? So what that we could, for an example, we could say if we double the mass, what happens to our kinetic energy? It also doubles. Same thing happens to the other variable. So we double our kinetic energy. Okay? So if I put some numbers to this, right? Let's say our mass is 3 kilograms. Okay? And our energy, we'll say, is 8 kilojoules. Okay? What if I double this mass? What does it become? Becomes 6. To double, you just take it times 2. So now I have 6 kilograms. What happens to my energy if I double my mass? Yes, I also multiply it times 2 because I also double it, and I get 16 kilojoules. Okay, so on an assessment, that makes it really easy. My mass is 2 kilograms, and I'm going to double it. What is my kinetic energy? Okay, you just do the same thing on both sides. Okay, now speed versus kinetic energy is different. Okay, let's check out the speed versus kinetic energy graphs that you guys created. This is the one of the SUV. Okay, what's different about that graph compared to the mass graph? Yes, it curves upwards, doesn't it? It's not nice and flat. So it's not a linear graph. What kind of graph is it? Exponential. It's nonlinear, okay? And the type of nonlinear graph would be exponential, okay? So it is instead of linear graph, it is an exponential graph. Okay, and you can draw a quick little picture on the side just so you remember what exponential looks like. I can tell right away that it's exponential because it curves. Okay, so now instead of both variables doing the same thing, it's exponential now. Okay, so if I triple my speed, let's say, what happens to my kinetic energy? Goes to the power of 3. Yep, very good. Yep, it increases to the power of 3. What if I quadrupled my speed? KE would go what? To the power of 4. Okay? If I took my speed times 5, what would my kinetic energy do? To the power of 5. See how that works? Okay? So we can do this mathematically again. What happens if my speed was 2 miles per hour? And let's say my kinetic energy was 2 kilojoules. And I'm going to triple it. Okay? Tripling my speed. So what would my new speed be?
6.
Yep, tripling it. So I would take it times 3. So I would get 6 miles per hour. But what would happen to my energy?
6, 8,
I would take 2 to the third. What's 2 to the third? Tricky, tricky. Nope. 2 times 2 is 4. Times 2 is 8. Okay? And that can be calculator work. It totally can be, okay? So remember, 2 to the third means you're taking 2 times 2 times 2. All right, so knowing what we know about the relationships, the graphing relationships between mass and kinetic energy and speed and kinetic energy, who has a bigger impact? Speed does. So let's write that down. Speed has a bigger impact on kinetic energy. Okay? Because why? How can I tell? Because it's what kind of a graph? It's exponential, okay? And it increases faster, okay? So because it's an exponential graph, okay? It increases faster. Another way you might see this is because it has a higher slope. Okay? That would work too.